Good Tuesday to you, everybody in Gov 603. Welcome to week 4. Kabam. How's everybody doing? You hanging in there? About a quarter way through the semester now. What do we got? January 31st, so almost February. Yikes. Where is the time going? I mean, you feel like you have to run as fast as you can just to stay in place, as the Red Queen said. So speaking as fast as we can, let's get a little jet fuel in us here. Let's see what cup do we have here? Short Wave Coffee, one of my favy cool local coffee spots. Thanks to them so much for the cup. Okay, that's much better. I am here, Dr. Gardner, your now sufficiently caffeinated instructor, to go over readings and research designs and midterm exams and all kinds of stuff. So, I deeply apologize for the delay in getting you feedback for your research designs. Everybody should have something in the way of feedback from me that is back in the discussion board for week 2. By way of general comments, I think you have some very interesting stuff going on. All right. Try for more specificity. I know you get interested and you go, oh, what about this and what about that? Excuse me, let me get a little lozenge for my throat or a curiously strong Altoid. And yeah, it's all good stuff and it's all interesting. But remember that all research has limitations, and all research has at least 2 limitations: time and access. How much time do you have to get to the stuff that you need? And you only have till the end of April. So many of you will receive comments like, narrow it down. Okay. And then number 2, remember that a good research question and or a good hypothesis, those are your friends. Be good to yourself as a researcher. Try to frame what it is you're interested in the form of a solid hypothesis. Why do you want to do that? You go, I'm not in that groove, man. I'm more of a free flow thinker. Okay, yeah, but you don't have time to be a free flow researcher and writer, because you got to have this done. Part 1 of this, remember, we're doing 2 parts, 1 paper, 2 parts, 1 paper. Part 1 is due February 24th. All right, that's what, 3 weeks and change from tomorrow? Which, by the way, of semester time, I know is forever. But since you don't have forever, you don't want to freeform this. A good solid hypothesis. Remember the 3 parts of a hypothesis. Number 1 has at least 2 variables. Number 2, you're making a prediction about a causal relationship between those 2 variables. What do we mean when we say causal relationship? This causes that. This affects that in some way. And then number 3, that has a direction. Okay. Something real simple. The more chapped my lips are, the more lip balm I will put on. All right. And if we put that in research speak, we'd say the relationship, the level of my chapped lips is positively correlated to the amount of chapstick applied. So we have 2 variables, my lips and the chapstick. We have a prediction about a causal relationship. The more chapped the lips are, the more chapstick hits the lips. And we have a predicted direction. Chapped lips brings chapsticks. Not more chapsticks brings more chapped lips. Okay, and you might be saying, well, that's stupid because chapstick doesn't chap your lips. But what if it was something else? The more chapped lips I have, the more, I don't know, pick something, coconut oil I rub on my lips. Why not? Take a pork chop. Okay. 2 variables. I've had dinner too. I don't know where that came from. 2 variables, a prediction about their causal relationship, this causing that, okay, and then a direction. So when you start with a hypothesis, this narrows down your topic. Bam, you don't have multiple issues. Well, I was thinking about the government, and I'm not talking about any in particular, so I'm not making fun of anybody. I was thinking about the government, and how it does this and that. And I was thinking how it affects people over here and those people that walk on their hands. And get a good hypothesis to be good to yourself as a researcher. So it narrows your topic. It will dictate to you very clearly the type of survey instrument or research, questions that you got to have. We're going to talk about more about that as the semester goes on. Okay, but most importantly, coming up for this first part, a very specific research question will help you focus your literature review, because you don't want to have to be pulling out works about everything, 4 or 5 or 6 separate topics. I mean, hey, if you got lots of extra time on your hands, knock yourself out. I mean, you've got that much time on your hands. Come over to my place and shovel my walks, because I got like a whole list, yay long, of stuff I'm trying to get to and just can't seem to get around to. But I'm guessing you don't have a lot of time. So a good, tight hypothesis, all right? They are your friends. Trust me. Trust me on this. All right. I know I said something last week, but I'll say something again. Over in the assignment folder is a review sheet for your midterm exam. I want to emphasize that we are not, repeat, not going to do is I'm not going to write a test that focuses simply on the items that I have listed on that research sheet, See, now I got myself saying it. On that review sheet, okay? Those are just examples. Excuse me, again. What we're going to do is we're going to take the material from the discussion boards week 1 through 8. So I'm imploring you, begging you, please stay current on the discussion boards, okay? Very important. Stay current on the definitions of items. Stay current on being able to describe and not just define, but to describe them. And when we say describe, what does it mean? Okay. On the major authors that we're reading and on the concepts. Just stay up to date week by week on the discussion boards, and you'll do fine on the exam. And if you don't, you're not going to do so great. All right, that's been my experience. Okay, so get that review sheet and just stay up, and you'll do just fine. And I know the exam is not until like March. It's a month from now, but I'm going to wait till the last minute. Okay, let's take a look at the questions from week number 3. And excuse me, some of your answers. Question number 1, define and describe. See, right there, when I mean describe is, can you explain what it is? The following terms: means, median, mode, standard error, variance, and standard deviation. Okay, these are, sort of the stock terms and terminology that you find in statistics. Not by a long stretch, all of them. Or no. This is generally true. And it's not just statistics or computer science or whatever. Any specialization, they can't help it. They have to develop their own specific vocabulary. I mean, in some ways, there's reason for that, because they're doing things specific to that discipline. Okay. But this is just a communication, a human tendency within communication is to tease out and then codify specific jargon, a common language, if you will. Okay. And these are some of the common terms of the common language of statistics. All right, Tiffany, let's take a look at what you did. Means. The means is what you get if you add up all the observations you have, then divide by the number of observations you have, and then divide by the number of observations. Okay, did I read that right? Because I think you said the same thing twice. The means is what you get if you add up all the observations you have and then divide by the number of observations. Yeah, I don't think you need to type that twice. That's right. That's the means. Okay, and the means is, right in the middle. The median is measuring a central tendency of the data instead of trying to produce a representative. As the means says, the median gives the representative observations. To find the median, Order the numbers from smallest to largest, then find the middle number. Okay, and this is literally the middle number in the set. And it will, since you're ordering them largest to smallest, it will come out to middle number in size. But sometimes, as in the example that you give here, Tiffany, 1, 2, 3, 5, 5, 8, 9. Since 5 is the middle number, it's not 5 and 5. It's not 5 because there's another 5. It's that on the one side of the 5, there's 1, 2, 3 numbers. And on the other side of the 5, there are 3 numbers, 5, 8, 9. Everybody see that? So you find the center point of the numerical teeter-totter. That's the median. Okay, the mode is the most frequent value in a data set. Yeah, so for example, and you give a good one here, Tiffany, 2, 2, 4, 5, 8, 9, 1, 3, 4, 2, because it's repeated twice and the other numbers are not. Standard error measures the accuracy with which a sample distribution represents population by using standard deviation. Okay, and let's go to standard deviation because this is one that we spend a lot of time with in statistics. It measures the amount of variation of a set of variables. Okay, so when you have a standard bell curve, you get the y and the x-axis, and then goes the bell curve. Right up the center is the means, and then as you go left or right from the top of the curve, you start going left, and this is the extreme in one direction. You start going right in the extreme in the other direction. The mean begins to expand out until you get to when you get to the tail end of the curve. From there into that there's sort of a corridor down the mean. That's the standard deviation. Why does anybody care? All right. Well, that's interesting. The obsession with standard deviation in statistics. Because I think this is easier to understand as Christian learners, such as we are here at Regent. If you begin with the assumption, as Christians do, that the physical plane we live on has an order to it, it is an ordered environment. And this is not an act of, this is not a proposition of faith. This is an expression of Newtonian physics. Things that are ordered have orderers. So, for example, if you took a dump truck, a truckload of bricks, and you drove out into the field and you just poured them into a pile, that is disorder. Okay, now yes, the brick is constituted and there's some order there, but we'll set that aside. And you went back in a year, would you expect to see a wall that would have spontaneously resulted from this pile of bricks? Nope. What if you went back in 10 years or 100 years or 1,000 years or 10,000 years? Would you expect to see that the bricks order themselves into an ordered structure? No, you would not. Okay, so our reality is an ordered reality, and order has constants to it. And I think this is probably, we're going to get to the Pareto distribution, and that and I put that out there on purpose because there's an important point both about statistics and about politics in this statistical phenomenon that we're going to get to. But I think one of the things that upsets us, that's what I'm looking for, is we don't like the thought that in the aggregate, taken all together, our behavior is similar and predictable. But it is. And so we expect some deviation from the means. But if you gather data and you've got instead of a curve, you've got like a bell curve, you've got like a curve that like skews way over to the left and the right. So you've got a really weird means point and a weird, deviation going left or right. Something may be wrong with your data. All right, how it's gathered, what you got in there. Maybe you had some data points that were really crazy off the scale because they were gathered, they weren't gathered right, or they're just not representative of the phenomenon that you're trying to measure. Something. Okay, so we spent a lot of time with standard deviation. Okay, standard error measures the accuracy in which a sample distribution represents population. So in other words, if you have something that is really crazy out of the standard deviation, that may not be valid to imply to the population as a whole, because again, we don't like this, but we behave in patterns. I mean, we shouldn't really be upset by it, because without pattern behavior, life doesn't exist. Life is in itself pattern behavior. I guarantee you that if your heart starts to contract in a random pattern, I mean, if the muscle has a consciousness next to the heart, you're going to be the first one to know that by way of pattern behavior, something ain't happening right in here. And then you fall over, just like kabam. Okay. Variance. Variance is the measure of variation that forces one value and is derived from the mean. This means you have to figure out the variance between each data point relative to the mean. Okay, we're going to come back to this a little bit later. All right, but that's good. Tiffany, this is one of those answers where I'm not going to read a bunch of people's stuff, because it is what it is, except be able to define what these things are, meaning what do they mean, not just give me a straight answer. So if you're not clear, and I get it, you're getting new vocabulary, go look it up. Okay, question number 2. List and describe the 5 variables listed in chapter 3 of the effect. Okay, Warrington, continuous variable, variables that could take any value. Count variables, those are counted, something that's counted. I'm going to go back to this in just a second. Ordinal variable, variables where some values are more or less than others. Categorical variables, recordings which categories an observation is in. And qualitative variables, a sort of catch-all category for everything. All right. For the purpose of this class, I want you to focus on those first 4. Continuous, okay. Count, or we sometimes say we collapse count and ordinal together. All right. Ordinal and categorical. Why do I want you to focus on those? Those types of variables produce the 2 types of data that you deal with in statistics. The one data we call categorical data. And this is easy to remember. Okay. Categorical data. So whether you count it up or it's ordinal, okay, we're going to come back to that. But categorical data is just that. Things are in this category or that. Yes, no, male, female, did not. Okay, very simple, straightforward categories. Now, how you ask the question about, or to the subject, to the person, can determine what kind of data that you're going to get. So I don't want you to be confused. It's not like data is like, these pens. There's this green plastic one and this black metal one, both fountain pens, both beloved by me. Yes, I have a lot of fountain pens. No. It's how you gather the information that makes it into either continuous or categorical. Okay, so example, if I say, let me use this example. If I say in a survey, what's your gender? And I give you 2 options, male or female. All right, that creates a categorical variable. Bam, I've just created 2 categories, and every one that takes a survey is going to drop into one or the other. But what if I say, and I'm sorry, I'll play the game here for just a second. What if I say, how many times a week do you identify as male, and how many times a week or a month, all right, do you identify as female? Now I've created a continuous variable concerning your identity vis-a-vis gender. Okay, because you say, well, like 5 times, 10 times, males, females. Okay, so but let's say that everybody in the survey that's male identifies as male, and that's female identifies as female. That is, there's no gender dysphoria in your survey data. that's still coming out as a continuous variable. Okay. So we're going to come back to that, but these are important definitions and concepts for you to wrap your head around. If you've got any questions about them, email me. Okay. Question number 3. Yes, I put this in there on purpose. I had a couple of people actually email me going, I don't know if you've looked into the discussion board, which I do actually follow it throughout the week. But man, there's a storm that got loose in there. And I'm like, yeah, I know. Okay, so the question is, watch this presentation by Professor Jordan Peterson, and there's the YouTube link. After watching the video, please answer the following question. If the Pareto distribution operates as Peterson claims, are government initiatives like income redistribution an effective means to reduce poverty? If you are unsure what income redistribution means, acquaint yourself with the process before answering the question. Okay, because I want you to understand the parameters before you start talking about it, all right? So it's not like, we don't make any assumptions, and that's fine. Okay, why did we have this question in here? Okay, 3 reasons. Number 1, this is an excellent example of how statistics are used within political science to describe behavioral phenomenon. That is what happens when people do stuff. In this case, exchange goods, services, money. Okay. That's the first reason I put it in there. The second reason was I wanted to give you a real world example, and I've got others in the semester, a real world example of how it is that even though statistically, number wise, if you by the way, the Pareto distribution does operate in the way that Dr. Peterson says. One of the interesting questions, and there's a lot been written about this, is why does it operate that way? It is a predictive model of distribution outcome that is repeated over and over and over in all kinds of distribution scenarios, whether people are swapping money, they're swapping, goods for services, people are producing creative material that attracts audiences, so they're swapping, intellectual property, say like a song for money or for concert attendance or whatever, over and over and over. The distribution comes out that way. And some, as you pointed out in your answer, this is sometimes referred to as the 80-20 model. Okay. Well, the second reason that I put it in there is I wanted to give you an example of how even when you have established statistical phenomenon, when you get into the operations of politics, that may not make any difference. Because if you look at this distribution, this sort of, there's sort of a wake up like, oh my gosh, we can keep taking money from people that have money and giving it to people who don't have money. And then as the exchange of the money within economies goes, let's say then it goes back to this distribution where everything is piled up on the left of this inverse bell curve, so it's not curving up this way, it's curving down this way. So let's say if we just took all the money from all the billionaires, eat the rich. All right. And we gave it away to everybody. Everybody got a single payment or a bunch of payments over the course of so many months. Okay, let's just pretend. The distribution, the statistical phenomenon, the outcome phenomenon of the Pareto distribution dictates that within, and I don't know what the span of time is, okay, but within a given specific span of time, as exchange of that money occurred, it would go back towards the left. Now, I'm not saying it would go back to the people that you took the money from, but it would go back to the left. That is, a concentration of the people with the most amount of money would be way up here, and then it would tail off, clear over to the right until you got out, to absolute zero. Okay, so which raises the question, why do we do something politically that in terms of how the process works is ineffectual? I mean, there are a lot of answers for that. I'm going to leave you to think about that. Why is it that political persona and political parties preach processes that aren't going to work. I mean, there's probably, we can make allowances for ignorance, either willful or otherwise, sort of premeditated ignorance. They just never bother to find out, or when they heard it, they just like, yeah, or they just don't know about this well-established distribution phenomenon. Okay, I want to say something let me get to a couple of your answers. What you saw, some people said, well, since this was a game. No, that's not what Dr. Peterson was saying. He said that imagine, here's how you can demonstrate this distribution. If you played a game where, let's say, you put 1,000 people in an auditorium, all right, and you gave each one of them $1,000. So everybody is exactly income equal from the start. And then each person had a quarter in their hand. And they turned to the person on their right or their left, or they did, you blew a whistle and you said, go, and you started playing a game. And one of the two persons would flip the quarter. All right. And you've already decided in advance, heads, you give away $1. Tails, you get $1. Okay. And you just said go, and there was all kinds of turning to the left or the right and quarter flipping and dollar exchanging. If you sped up like Peterson does in that graph, if you filmed this and then sped it up, you would see that the concentration of the $1,000 per person gets pushed way over to the left. That is, about 20% of the people in the room will end up with 80% of the dollars. Now, the question is why? Or maybe even more relevant, how do you end up on the left side of the inverse curve and not the right side of the inverse curve? Well, it is not completely random. There are things you can do to increase your chances of ending up on the left side instead of the right side. That is, you have to, first of all, make sure that you have units to exchange. You have to have income. Because if you don't, and you're already on the right side, you're already down towards absolute zero, you're out of the game. Okay, and this is the point that Peterson makes. So number one, you have to make sure that you have a revenue stream. Number two, you have to engage in the process of both getting, that is getting paid, and giving, that is giving service. You've got to participate in that exchange, back and forth, back and forth. As your rate of participation goes down, your rate of accumulation goes down. And this is, there's sort of the cliche of it. You have to have money to make money. And that sort of popped up, meaning, well, you can't make any money because you've got to have a lot of money. Well, okay. You don't have to have a lot of money. You just have to have discipline in terms of the habits and applications of those first two features. That is, getting the units of exchange, exchanging the units of exchange, and being patient and disciplined about that process. So there are things you can do in life to put yourself further to the left than to the right. It's not completely random. But what Peterson was trying to explain, the point that he was trying to make, is when it operates, if you take out all the smart decisions that people can make, just all on its own, in terms of a statistical phenomenon, it skews to the left. And it does this over and over again. So as people that are thinking about policy, and you may be in a position in which you're advising policy one day, and you may be asked to find statistical data to support or underwrite or push the policy forward. So as a matter of consideration of where statistics meets policy, this is a very, very good example. All right, let's take a look at what some of you said. Ariel, after watching the video and educating myself on the term income redistribution, I'd have to say that income redistribution would not affect means to reduce poverty. Why? Well, first, when looking at the Pareto distribution and how people who do make more, for instance, big corporations, the higher bosses don't work nearly as hard and make way more than the manual labor employees. Okay, that's not what the distribution is saying. Okay, it's not saying that the people at the top of the corporations don't work, because first of all, I assure you that they do. I mean, I've worked with and had clients, some pretty big corporations and entities. I mean, like whole universities. And I can tell you that, even somebody that wears a white collar as opposed to blue collar, as the expression goes, works plenty hard. The work is different. Okay. And look, and I come from a very working class background, and I've worked hard manual labor jobs most of my life. I worked through my undergraduate years as a construction worker. I did everything from concrete to ironwork, that is assembling the iron girder structures of tall buildings. And I worked hard. I worked a lot. To this point specifically, remember this, and this is, slightly off topic of political science, but it's a good economic maxim. Okay. Within the marketplace, we are rewarded not for the intensity of our work. And you might say, well, that's not fair. That's the way it works. But we are rewarded rather for the value that our work product brings to the person rewarding us. So if we flip a hamburger and we say, well, we want $15 an hour. So let's say yesterday we got whatever the minimum wage is. I think in the state that I live in, it's like $11.95. Let's just say $12. All right. So yesterday, turning the hamburger was $12 an hour. Today, you say you demand $15 an hour as a minimum wage. Turning the hamburger is $15 an hour. Is there $3 more an hour worth of value in that hamburger? No, there's not. So the rate at which you're compensated is directly proportional to the value that you bring to the work product. That is, what's the thing at the end of what you're doing. Okay, but back to you, Ariel. Second income distribution is a statistical measure of how many people earn or receive various amounts of money. With that being said, Dr. Peterson displays a chart in this video of distribution of income and how, at the end, no matter the starting point, people at the top always continue to receive more money. Okay, and again, I want to clarify, that's not what he's saying. Not people at the top. Because that was the point of constructing the game. If you start with everybody exactly even in terms of the amount of money, this you could call this a law of movement, of exchange. It's sort of like, gravitational constant, things falling off a building. Okay. So it's not the people that start with more money that end up with more money. It's that as the exchange goes, even if it's completely random, just based on the flip of a coin, the distribution skews hard to the left. While people at the bottom in poverty will remain in poverty. Well, that's true, because if you don't have units to exchange and you're already on the right, then you tend to get stuck on the right. This shines a light on Matthew's principles. To those who listen to my teachings, more understanding will be given. They will have an abundance of knowledge. But for those not listening, even what little understanding they have will be taken away. All in all, everything leads to income distribution not being a good way to reduce poverty in a way. Okay. Good answer. Okay. Judah, Dr. Peterson's lecture upload. He describes parameter distribution. In this distribution, most of the data is located near zero. The amount of data underneath the curve decreases exponentially as independent variables increase. However, there's a small part of the distribution that extends far above zero. Dr. Peterson sees any creative and economic productivity activity as likely to fit the Pareto distribution, and it does. I mean, if you take a look at how it shakes out. In other words, most people who engage in an activity will have very little productivity, but there will be a select few who will have massively overproductive compared to everyone else. Dr. Peterson also theorized that moving towards zero on a scale creates positive feedback loop, which pushes the person even closer to zero. In other words, you just stop participating. You go, what's the point? When we say feedback loop, what he means by this, and we use this in political science too. You do something, you get you get a sense of what happens when you do that thing, and then you either stop doing that thing because of the negative consequence, or you keep doing that thing because of what is perceived as a positive consequence. That's a feedback loop. Okay. And it doesn't mean, feedback is good or for you or bad for you. It just is what it is that you get. Okay, towards zero scale feedback loop pushes person even closer to zero, while someone moving away from zero will create positive feedback loops, which pushes them further away. In other words, as this distribution, again, if everybody starts with equal amounts of money, as this distribution starts to move, some people that see a decrease in their money stop participating. And as they stop participating, their opportunity to accumulate wealth stops. This is in the game where everybody has $1,000. And you might say, yeah, but they don't lose anything either. True, not based on what they're holding, but relative to everyone else. Yes, they do, because they get stuck right where they are. Those that keep at it tend to get pushed to the left. Okay, the basic idea does not seem to back, the basic data does seem, to back that piece up. For example, the chart from U.S. Census Bureau, and that's an excellent chart, by the way, Judah, about income distributions from 2014. Okay, so let's jump down. The purpose of the government's goal was not to redistribute wealth, but merely to reduce poverty by moving the peak. But suppose, you say, meaning the peak of the curve from the 10th percentile to the 30th percentile. Is this sustainable in the long term? That's a good question. If we assume the operation of the Pareto distribution, the answer is no, because then when you create an artificial peak, it's going to tend to push back. To be honest, I don't know, and I think that if political scientists and economists were able to conclusively state it was sustainable, there wouldn't be a need to write this discussion board post, which is a good point. Society is complicated, but what I can say that is that even if the government could succeed in moving the distribution peak, it would always be fighting the Pareto distribution to pull it back towards zero. Okay. All right. And I think that's very well put. People, societies are complicated because people are complicated. Okay. And one of the issues that we run into is in a free society. What does that mean? Remember, there's two sides to the coin when we say free, because you're not free unless you're given the capacity to really mess it up. If I force you into participation, it's like voting. A free election is not an election in which you are compelled to vote. I'm not saying don't vote, but that's not an election, because freedom means the option to do nothing. Now, that's not a good option. That's not an option that's in the individual or the collective best interest. But that's one of the rocks in the backpack of a free society, is the option to do nothing. And can you compel people to do something? Well, some say, well, there's work to welfare. Meaning, if you're going to receive government benefits, you have to work, and you can only receive them, speaking of income distribution, you can only receive them for a certain amount of time, and then you have to find a job. Some very interesting numbers came out of the welfare to work program that was put in the 90s during the Clinton administration, that pointed to exactly this phenomenon. That is, the number of people on long-term public assistance dropped as the requirement to work to maintain the benefits for a specified period of time went up. So outside of that, you cannot compel people to go to college. You cannot compel people to continue to compete in the marketplace and engage in this distribution. You cannot compel people not to develop negative feedback loops. You have to work very hard. You should work very hard. We should work very hard as a body politic at discouraging those behaviors which harm the individual. But compelling them, tough gig, man. Tough gig. Okay, let's wrap things up. Question number 4. According to Alan Smith, why should all people be interested in statistics? I don't know if you were convinced by the video. There you are, stroking your chin, going, yeah, I never thought about it that way. Statistics are about people, and I love people. I mean, isn't there a built-in assumption there that what if you're like a dog person or something? I don't know. But anyway, Richard, I like what you said. I think you went first, so we take you last. All people should be interested in statistics because statistics is about us as a group, and the results of statistics surprise us. Okay, and then you say, I agree with Alan Smith's reasoning and agree that statistics has an image problem. In addition to image, many have a legitimate fear of statistical formulas. I actually love the study of statistical evidence and research. However, it is a love-hate relationship. I have two. I have my undergraduate degree. I have a bachelor's in biology and a bachelor's in language and philosophy. So I understand this dichotomy, this love-hate that you talk about, Richard. I get where you're coming from. I actually love the study of statistical evidence and research. However, I struggle with some of the concepts and formulas of statistics. I identify statistics with eating healthy and engaging in daily exercise program. I know it's for my well-being, but the dread of daily discipline the daily discipline of associated that's associated with it. You read that. You wrote that right. I read that wrong. Sorry. All right. Excellent answer. So yeah, statistics is about us, and the same true for political science and communication. That's us studying us. So we should be interested in that because, unless we believe that aliens hiding behind the moon are going to solve our problems, that's us. All right. Okay, everybody. Good job. All right. So make sure you tweak those research design proposals. You don't have to send them to me through email. In fact, please don't. But if you want to, throw it in the post, respond to my comment, please. That's fine. Then I get a notice. I can take a look at what you did. That's fine. Get over there and get your midterm exam review sheet so you know what's going on. And remember, stay current on the discussion boards, and you're going to do great. Okay, everybody. I think about you. I pray for you. And I will see you again next week and on Blackboard. Take care. God bless.